Here in the I button and description box below you will get complete playlist of partial fraction. Now I welcome you to video number 3, and in this video we are going to solve, yes, type 3 of partial fraction. Okay, yes, in the previous two videos we have solved 5 problems, 5 different problems, or you can say 5 examples of type 1, and in the second video I have solved 3 different types of problem in type number 2, and in this video we are going to solve 2 different type of problem on type number 3, that is in which the denominator contains non-repeated irreducible quadratic factors. Okay, non-repeated irreducible quadratic factors. Okay, quadratic means x to the power 2 in the denominator part. Okay, in denominator part we have irreducible quadratic factors. Okay, non-repeated irreducible quadratic factors. Okay, highest power of x will be how much? 2, because of this quadratic factor. Okay, yes, before I start this video I would request you to subscribe to my channel, and if you learn something from my videos then please hit the like button and do share the playlist of this chapter with your friends. Okay, please share the playlist of this chapter with your friends. Now let us start. Under this type 3 we are going to solve two very important problems, that is x square upon x square minus 1 into x square plus 2. In the second problem, that is 3x plus 1, we have denominator part is x minus 1 into x square plus 1. Here you can see this is irreducible. Okay, irreducible quadratic factor. Here also we can see this is irreducible quadratic factor. Okay, yes, but we will solve this second problem first and then we will solve the first type of problem. Okay, yes, let us start with the second problem, that is 3x plus 1 upon x minus 1 into x square plus 1. So yes, a upon x minus 1 plus, yes, here we have x square. Okay, yes, I have already told you in the second type of problem, that is the numerator part. Okay, the highest power of numerator part must be lesser than the highest power of x in the denominator part. Okay, because of that only here we have x square, so we need to start with x. Okay, so numerator part of this will become bx plus c. Fine. Okay, so take LCM. Here have x minus 1 into x square plus 1 in the denominator part. This will be multiplied with this will be multiplied with this. Okay, that is a into x square plus 1 plus bx plus c into x minus 1. Okay, yes, now if you compare these two, the denominator part will get cancelled, so we will be left with 3x plus 1 equals to this numerator part of this. Okay, that is a into x square plus 1 plus bx plus c into x minus 1. Okay, now here, yes, if you observe, if you put x equals to 1, so this will become 0, so this whole term will become 0. Okay, so here we can find the value of a, that is I'm putting x equals to 1. Yes, here we have 3 plus 1, that is 4. Here that is a into 1 plus 1. Okay, because 1 square is 1, 1 plus 1, that is 2. On solving this you will get a equals to how much? 2. Okay, yes, now we need the value of b and c. For that we need to expand this. Okay, yes, we need to open this bracket. So 3x plus 1 will be as it is. Yes, open this bracket, you will get a x square plus a. Okay, here we have bx square minus bx, cx minus c. Okay, yes, we want the value of b and c. Okay, for finding the value of b and c, yes, for finding the value of b, here you can see x square coefficient as b and coefficient of x is also b. Okay, so either we can write coefficient equating the coefficient of x square or x, you can find the value of b. But here also for c also, which is unknown to us, the coefficient of x is what? C. So it is better to take coefficient of x square. Okay, so yes, here you can see a, and a is known to us. Okay, so we can find easily the value of b. So equating the coefficient of x square, you will see here we have no term that contains x square, so here we will write 0. Here we have a and here we have b. So a plus b equals to 0, so b equals to minus a, and what is a? 2, so b equals to minus 2. Okay, now for finding the value of c, we can either equate the coefficient of x or we can equate the coefficient of constant. So equating the coefficient of x, here we have 3, here we have minus b plus c. Okay, so we want the value of c, take this b here, so 3 plus b equals to c. So 3, what is b? Minus 2. So c equals to 3 minus 2, that is 1. So here we have a equals to 2, b that is minus 2, and c that is plus 1. So here we can see values of a, b and c are yes here. So we are going to put the value of a, b and c here, yes, here. Okay, then we can say like we have solved this part, that is partial fraction of this. So yes, 3x plus 1 upon x minus 1 into x square plus can be written as a upon x minus 1 plus bx plus c upon x square plus 1. Write the value of a, that is 2 upon x minus 1 plus what is b? Minus 2. Minus 2x plus what is c? 1. So this upon x square plus 1. We can rewrite this as 1 minus 2x upon x square plus 1, and this term is as it is, and this is what? This is my final answer. Okay, now coming to the first problem, that is this, that is x square upon x square minus 1 into x square plus 2. This is yes, this is non-repeated irreducible quadratic factor. Okay, yes, a square minus b square. Applying this formula here, you can write this as x plus 1 into x minus 1, and this is as it is. Okay, x square upon this. So a upon this plus b upon this, plus here we have non-reducible quadratic factor. So we are going to write cx plus d. Oh my god, we have 4 unknowns. Okay, that is a, b, c and d. Well, it doesn't matter because finding a, b, c and d are very easy. Okay, so if you take LCM, so with a, this and this will get multiplied. With b, these two terms will get multiplied. With this, these two will get multiplied. Okay, yes. So on equating this with this, denominator part will get cancelled. So we can say x square equals to this. Okay, now from here we can find certain values. Okay, yes. So if you see here we have yes, with b we have x plus 1 and x square plus 2. Okay, if you see here, if you put x equals to minus 1, okay, so this term will get cancelled. Similarly here also, since x equals to minus 1, so minus 1 square, that is 1, 1 minus 1, that is 0. So on putting x equals to minus 1, these two terms will get 0, become 0. So we can easily find the value of a. Okay, so put x equals to minus 1, this will become 1 because minus 1 whole square, that is 1, equals to a into minus 1 minus 1, that is minus 2, minus 1 square, that is 1 plus 2, that is 3. Okay, and rest of the terms will become 0. So from here we will get a, that is minus 1 upon 6. Fine. Now coming to yes, again, okay, here if you put x equals to 1, okay, if you put x equals to 1, then this term will become 0. Okay, and this will also become 0. So we can find the value of b. Okay, now put x equals to 1, this will become 1, this will become 0. So a into 0, this, that is b into 1 plus 1, that is 2, 1 square, that is 1 plus 2, that is 3. Okay, here also yes, 1 square, that is 1 minus 0, 1 minus 1, that is 0. So this term also becomes 0. So from here we can find the value of b, that is 1 equals to b into 6, that is b equals to what? 1 upon 6. So we can say we have the values of a and b. Now we need values of c and d. For that we need to open this bracket. Okay, yes, x square a into multiply this, okay, plus b into multiply this, open this bracket, then again multiplying these two brackets, you will get these 4 terms. Okay, that is cx cube minus 3x plus dx square minus d. Okay, yes. Now if you see, to find the value of c, we have you can see here c is present in 2 terms. Okay, so we can compare either coefficient of equate the coefficient of x cube, or we can equate the coefficient of x, so that we will get the value of c. Okay, but here we are equating the coefficient of x cube. Okay, here we don't have any term that contains x cube, so we need to write here 0. Here we have a, here we have b, okay, and here we have c. So we can say a plus b plus c equal to 0. And what is a? Minus 1 upon 6. What is b? 1 upon 6. So a plus b is going to be 0. So c equals to 0. Okay, now to find the value of d, we have, you can see here, x square coefficient is d, and constant coefficient is also d. Okay, constant is also d. So either we can equate the coefficient of x square, or we can equate the coefficient of constant. We are going to get the value of d. Okay, same value of d. Fine. So here we are equating the coefficient of x square. So here we have 1, Here we have minus a, okay, x square, my coefficient is minus a here. Here we have plus b, okay, and here we have plus d. So we can say the equation is 1 equals to minus a plus b plus d, okay, yes. So to find the value of d, this a and b, okay, goes to this, okay, we can take this part to the LHS side, that is 1 plus a minus b, okay, because if these two terms come to LHS, so this will become positive and this will become negative, okay. What is a? Minus 1 upon 6. What is b? 1 upon 6. With this negative sign, this is also 1 upon 6. So take LCM, that is 6. 6 minus 1 minus 1, that is 4 upon 6. And what is 4 upon 6? That is 2 upon 3. Okay. So here we can see the value of a is minus 1 upon 6, b is 1 upon 6, c is 0, and d is how much? 2 upon 3. Okay. We wanted to find the value of this, that is x square upon x square minus 1 into x square plus 2, which can be written as a upon x plus 1 plus b upon x minus 1 plus cx plus d upon x square plus 2. What is a? Minus 1 upon 6. Write it here. Okay. What is b? 1 upon 6. 1 upon 6 into x minus 1. Here we have minus 1 upon 6, that is minus 1 upon 6 into x plus 1. Okay. Here c equal to 0. So remove this term. We have only d, that is 2 upon 3 into x square plus 2. Okay. And this is what? Yes, this is my final answer. Okay. Yes. Thank you so much for watching this video. Thank you.